The last section of Chapter 2 is balancing chemical reactions or chemical equations. So a chemical reaction is a symbolic representation of a chemical reaction in terms of the chemical formulas. You have two parts. You have a reactant, which I have a figure down here that shows that these two are my reactants. They're always on the left-hand side of the reaction arrow. Then you have the reaction arrow that basically says that this separates from what you start with what you end with. The product is what you end with, and so the product's always on the right-hand side of the reaction. This one only has one, but you can have as many as you need. And then you have coefficients, which are the numbers in front of the chemical formulas that tell you how many of each compound or molecule that you have. Okay. You can also have the states of materials, so you have G for gas, L for liquid, S for solid, and AQ for an aqueous or water solution. Okay. Additionally, sometimes there are symbols that are above the reaction arrow. The delta sign here means that it was heated. Something like an element or a compound above this means that it has a catalyst. So how do you balance these chemical reactions? Okay, you add coefficients so the number of each atom is equal on both sides of the arrow. Okay, so I have one magnesium, but I have two oxygens here and only one here. So I'm going to balance this by putting a 2 right here. But when I did that, I changed the magnesium, so now I need to go back to those. So now I have two magnesiums, 2 times the 1, and 2 magnesiums, so I put a 2 there. Okay. So when you're doing this, typically you want to balance the atoms that only occur in one place on each side of the equation. And then this is kind of not always true, but typically hydrogen then oxygen, sometimes it's oxygen then hydrogen. And then make sure to double check at the end to make sure that you don't have some multiple of a number, because I will give you partial credit for that. So if I look at this, I have this one. I have 4 carbons here, and I only have 1 carbon here. So I would need to put a 4 in front of the carbons. I'm going to do hydrogen next, not oxygen, because oxygen is in 2 places on my product side. So if I have a choice, I want to do ones that are only in one place. So I have 10 hydrogens here, and I have 2 hydrogens here. What multiplier of 2 can I put? Well, I can put a 5. Oops. Why is it not? There we go. A 5, okay? Now I look at my oxygens. I have 2 oxygens here, and I have 8 here. So 2 times the 4 is 8, plus 5 times 1. So I have 13 oxygens here. Well, this is the oxygen molecule, and so every coefficient here I put is going to automatically be multiplied by 2. So therefore, how do I get an odd number 13? Well, I can't, so I'm going to put a fraction here. I'm going to say that this is 13 divided by 2, and now when I multiply by 2, I end up with 13. But I do want a fraction as my final equation. So what I'm going to do then is multiply by whatever the denominator is in this fraction, which this one's 2, is most commonly 2, but it doesn't have to be. It could be 3 for ozone or something. So I'm going to multiply everything by 2, so times 2. So I'll write down below, well, I'm going to just go right here. So 1 times 2 is 2. 13 halves times 2 is 13. 4 times 2 is 8. And 5 times 2 is 10. So this is my balanced equation. And of course, 13 being an odd number can't be divided by 2, so these are the smallest whole numbers here. So the balanced reaction is 2 C4H10s plus 13 O2s goes to react to form 8 carbon dioxides and 10 waters. Okay. So here's some practice. This is problem number 98. This one I've animated, so I don't need to write anymore. So the first thing I'm going to look at is calciums. Okay, I've got 3 calciums over here. Okay, I've got 3 calciums here. I've only got 1 here, so I'm going to put a coefficient of 3 in front of the calciums. I have multiple phosphoruses. I have phosphorus here, phosphorus there, and only 1 on that side. So I'm not going to use phosphorus. Hydrogen, I only have the one here and the one here, okay? However, how many hydrogens do I have? Well, this side I obviously have the 3, but this side I have 3, so for hydrogen, I have 3 times 2 times 2. So it's 3 times the outside of the parentheses, because everything inside the parentheses is multiplied by 2, times the fact that inside is 2. So I have 12 hydrogens here. So what coefficient can I put in front of this to get 12? And the answer is 4. Okay? And now, because of the fact that I have got only one product over here, hopefully my phosphoruses will balance. So over here, how many phosphoruses do I have? Well, with nothing written here, it's understood to be 1. Okay? So 1 times 2 times 1 is 2. Hold on. I've got 4 times 1 times 1 is 4. So that's 6 total. I've got 3 times 2 times 1 is 6. So that's a balanced reaction. With a coefficient of 1, there is nothing that can be done there. Okay? Next one. Okay? I'm going to look at the manganese first. I've got 1 manganese here, 1 manganese there. Okay? So there's no coefficients there. Oxygen is the other thing that's only in one place. I'm sorry, hydrogen. No, I'm going to do oxygen next. Oxygen, I've got 2 here and only 1 over here. Okay, so I'm going to put a 2 in front of the coefficient. Oh, I didn't make any. 2 in front of the coefficient there. Okay, now look at the hydrogens because it's only 1 and 1. So I've got 1 hydrogen here and 4 here. So I'm going to put a 4 there. And the last thing I want to look at is chlorine. Okay, I've got 4 times 1 is 4 here. I've got 2 plus the 2 is 4, so this is now balanced. The last one is I've got sodium thiosulfate plus iodine goes from sodium iodide plus sodium persulfate. That one's not one you have to know. Okay, I'm going to look at sodiums first. I've got 2, where am I at? 2, and, oh, I'm going to do sodiums last, sorry, because sodium's 2 different places. I'm going to start with sulfur. I've got 2 here, and I've got 4 there, so I need to put a coefficient of a 2 there. Okay, oxygens, I now have 2 times a 3 gives me 6, and I've got 1 times 6 is 6, so that one's fine. And now I'm going to do iodines next, so I've got I2 and 1, so I'm going to put a coefficient of a 2 there for iodine. And now we'll look at my sodiums. Okay, so everything else has been done. Hopefully my sodiums are done. So 2 times 2 is 4, so I have 4 sodiums over here. I have 2 times 1 is 2, plus 1 times 2 is 2 to give me 4. So this is a balanced reaction. Alright, the last problem has to do with taking the nomenclature and the balancing equations together. So I have the sodium metal, so I put down sodium and then symbolize it by reacts with means plus, water is H2O and typically a liquid. Gives means it's a reaction arrow. Okay. Sodium hydroxide is NaOH and it's solution, so therefore it's aqueous. And releasing hydrogen gas. So hydrogen is a diatomic molecule, so it's H2 as a gas. Okay. And then to balance this, okay, I look at my sodiums. Okay. I have 1 sodium and 1 sodium. I look at my oxygens. I got 1 oxygen, 1 oxygen. However, for hydrogens, I've got 2 hydrogens here, and I've got 3 here. Okay, so to balance, so I've got 2 hydrogens here, and I've got 3 hydrogens here. Okay, since this one's by itself, I can put a fraction here of 1/2. Okay, but again, I don't want a fraction there. But everything is balanced at this point. But what I can do is multiply the whole equation by 2. So I end up with 2 sodiums, 2 waters, 2 sodium hydroxides, and only 1 hydrogen. And this is the end of chapter 2.